In this video, we're going to wrap up chapter 1 by kind of connecting everything we've been talking about this whole chapter. This whole first chapter is just kind of giving us a basis or laying the groundwork for everything that we're going to be using and doing in pre-algebra for the rest of the year. So this last lesson kind of ties all of that together with words, equations, tables, and graphs, because those are the tools we're going to be using throughout the year. Equations, tables, graphs, representations of relationships mathematically. And some relations have a rule that relate the domain values, or our x values, and the range, or our y values. And we can express this rule as an equation. So an equation is a math sentence stating that two quantities are equal. So we can take relationships that follow a pattern and write them as a rule or write them as an equation. So let's take a look at an example here. So consider this rule: double a number and add 3. Okay, this rule relates to numbers, the number you start with and the result, what you end with. So we can express this rule or relation with an equation. If x is the number you start with and y is the result, then we get this equation: 2x plus 3 equals y, or 2 times x plus 3 equals y. Okay, so I can take any number, x, double it and add 3 to get my result, or y. So this relationship between these two numbers is expressed as an equation. So let's make a table of 4 different pairs or ordered pairs of numbers in this relation. So x and y are related by this rule: double a number and add 3. So if x is 1, then if I double that and add 3, 2 times 1 plus 3, I get 5. And if x is 2, if I double that number and add 3, I get 2 times 2 is 4, plus 3 is 7. And if x is 3, 2 times 3 is 6, plus 3 is 9. And if x is 4, 2 times 4 is 8, plus 3 is 11. So every pair of numbers here is related the same way. If I double the x value and add 3, I get the y value. So this is a special relationship that is described using the equation. So now we can see the rule, the words, the equation, and the table that represents this relationship. So then again, let's tie that idea of domain and range in here too. The domain of this relationship is 1, 2, 3, and 4. And the range of our relation is 5, 7, 9, and 11. So those are the ideas. Again, we're tying in what we've talked about in this chapter to kind of put it all together into those words and equations and tables and the domain and the relation, the domain and range of our relation. So let's write an equation that represents the rule. Then again, we're going to make a table of 4 pairs of numbers that make the equation true, and then we're going to identify the domain and range. So triple the number and subtract 1. So if I just pick a number, triple it, and subtract 1, I'm going to get a result. So again, this rule relates to values, and we'll call them x and y again, where x is our input and y is what we get out. So the equation here would be triple the number. So we're going to triple x and then subtract 1, and that's going to give us our result, or give us y. 3 times x minus 1 equals y. That's the equation for this relation. And now we need to find 4 pairs of numbers that make this equation true or fit this relation. So when it comes to x values, or values that we're going to triple and subtract 1 from, we can really pick whatever we want, but I'm going to be real creative here, and I'm going to pick 1, 2, 3, and 4 again. So then if I apply the rule to my input values, or my x values, I'm going to have 3 times 1 minus 1, which is 2. 2 times 3 minus 1, which is 5, 3 times 3 minus 1, which is 8, and 4 times 3 minus 1, which is 11. So again, all of these pairs of values are related the same way. They're related with this equation, or this rule of tripling the number and subtracting 1. And again, if I identify the domain of this relation is 1, 2, 3, and 4, and the range of my relation is 2, 5, 8, and 11. Okay, So tying that all together, here's kind of the multiple representations we're going to be using throughout this year in pre-algebra. Words is one way to describe a relation. Distance is equal to 60 miles per hour times the number of hours. And then we can write that as an equation. Distance is equal to 60 times t, or 60 times the number of hours, where t is the number of hours. We can also represent this in a table, where we come up with a table of actual values. If I travel for 1 hour, I go 60 miles. 2 hours, I go 120 miles, and so on and so forth. I can also represent the same relation in a graph. If I graph those ordered pairs, 1 hour is 60 miles, 2 hours is 120 miles, 3 hours is 180 miles, and so on. So different ways we can represent relationships between two quantities. Okay, this is a critical concept when it comes to algebra. Words, equations, tables, and graphs. So let's complete the table and state the domain and range of this relation. We're actually going to graph it too, so we can see all the representations of this relationship. And our relationship here is Bob spent 5 more than 3 times what Anna spent. So if we were to write an equation here, and we can see in our table where x is what Anna spent and y is what Bob spent. So y, what Bob spent, is equal to 5 more than 3 times what Anna spent. So Anna spent X dollars, so 3 times that would be 3X, and 5 more than that would be plus 5. So here's the equation. So we took the words, turned it into an equation, y equals 3 times X plus 5, and now we can fill out our table. So if Anna spent $2, that means Bob spent $11. If Anna spent $4, that means that Bob spent $17. If Anna spent $6, that means Bob spent $23. And if Anna spent $8, that means Bob spent $29. So we got our words, equation, and table. And then we can graph this relationship too to kind of see it visually. $2, $11, $4 for Anna, $17 for Bob, $6 for Anna, $23 for Bob, and $8 for Anna, $29 for Bob. So there's a nice visual representation of that relationship. And then finally, the domain and range. The domain of our relation is 2, 4, 6, and 8. Those are all the amounts that Anna spent. And then the range is all of the amounts that Bob spent: 11, 17, 23, and $29. So again, that's tying it all together, kind of a way to culminate chapter 1. Words, equations, tables, and graphs, all ways to represent relations of variables.